So good afternoon, ladies and gentlemen. So I'm Benoît Mathieu from OHB Sweden, Managing Director since early 2021 there. Thank you to IF and thank you to SNSA that have the opportunity today to present our product line InnoSat in this room. I understood from the program that, okay, the highlight will be at just after me, so I understand my task is to fill the gap between before and the next point. So to try to entertain you, I will be the opening band for the next half an hour. Before I talk too much on OHB Sweden, I will propose we start with a video, so as kind of entertainment, and after I will present you our product line. So let's hope the techniques works. Yes, one remark, if you have some questions, you can use the Slido app, and if it times allow, I may then be able to answer. Perfect. Okay, this tells more than many words. Just to complement, yes, we have been founded in 2011, but 30 years of heritage, how does it fit? It's because before we were the satellite division of Swedish Space Corporation, so that's why we have 30 years of heritage of all Swedish science mission. And that's also one of our key characteristics. We really master the satellites from the mission analysis up to the operations. We cover everything with our team. So, and that's one of our strengths. We have a very broad knowledge within 80 people. That's really an asset. Yes, and we have also a very diverse team. So we cover mostly, as you have seen in the video, 4 areas, or the 3, the main one plus one developing. That's the small sat. We are one of the leaders on the propulsion subsystem, electrical, but also chemical propulsion. And we have also a very strong competence in attitude orbit control system. And we are also having mission control software. So now about our product, InnoSat. So this is a small sat design, very robust, which is really versatile, which this can adapt to different types of missions, different types, size of payload. But it's not only a robust design offering the reliability you need for operational missions, it's also based on a robust team. And I mentioned our staff before, but also we have a strong link to our industrial team, which is supporting and delivering to us equipment with which we have strong ties, and they help us to develop and improve the performance and the competitiveness of our product. So reliability based on tune redundancy. Depending on the missions, we adapt the redundancy. Then we have, you will see, we have cases where we were able to deliver the satellite very quickly, so we are agile, customer-oriented, so we really adapt to what are the key needs of our customer. You see in terms of size, we have 4 different sizes depending on the size of the payload. Okay, in terms of performance, I won't go into detail, but we can have high agility or medium pointing performances. This is really modular in our design. The core is the avionics, which is always the same mission per mission, and all around can be adapted. We are qualified for different type of launcher. And also in terms of power, we can cover a wide range of missions. So let's come to the past mission, present missions, and the future. So this is a very important mission for us. MATS, why is it so important? First, it's because it's a new Swedish science mission. It's going to be launched now on the 1st of November in New Zealand, 31st of October in Europe. So we are very keen on this, thanks to the support of SNSA, the Swedish National Space Agency. And this is very important because this was the beginning. Thanks to this project, we were able to develop really the core of our InnoSat product. This was a kind of minimum viable product. It was quite a simple satellite. It is a simple satellite without propulsion, but it's not a problem because it's quite low in orbit. But this where we could develop the core avionics, the onboard software, the algorithms, which we can reuse now in each following missions. This is also an important mission because it will be the first time with a satellite that you can have a full 3D mapping of the atmosphere waves, which you have at the upper atmosphere, the mesospheric part. And this, so you have 2 instruments developed by the Meteorological Institute of the Stockholm University, KTH, Chalmers, and also an industrial partner, Omnisys. And this is looking at the small scale and the bigger scale of these waves in the atmosphere, looking at this noctilucent cloud, so that's the cloud you can see in very high atmosphere during the night. And this is really new, that you can map this in all dimensions. And this is a contribution also to understanding the atmosphere system. So this is a contribution also of understanding better our climate, how this evolves. So that's why it's a very important mission. This is a quite small satellite, you will see. That was the first one, and that's how we started. Next one, actually the first one who was put in orbit, but the second one in terms of development, it was really a fast-track project. There, the need was, a customer decided quite late that he had to secure his frequencies, so we had a very short time between the contract and also the freeze of the requirements and the launch. We had less than 7 months. So we put all our efforts to make this happen. And we really demonstrated that we are agile and that we can meet the deadline. And actually, we were in space and we could switch on the payload a few days before the deadline. We only needed 3 days to commission the platform and to make this happen. So this is also a good sign, I mean, the illustration how agile we can be with our team. Next, this is also the next step. MATS was the birth, and this is the further development. Also, thanks to the support of the Swedish National Space Agency and of ESA. As you see, there are 12 countries contributing to this mission. And this is really the next step, because there it's about developing a prototype model with improved redundancy, improved reliability for an operational mission. So the objective of this mission is to complement the current measures you have in terms of meteorological data to improve the weather forecast, especially a short term, but also in the Arctic region, because today, mostly you have geostationary satellites, so covering quite well the lower latitudes. but not covering the high latitudes. And you have a few satellites in polar orbit, but with a low temporal resolution. And the idea behind this mission is to complement this. So that's, as I say, ESA as a customer. It's a bigger satellite. We are now in the 120 kilo classes. And what is also particular in this mission, so just not to forget, the payload is from Omnisys, also a Swedish company. It's a cross-scanning microwave radiometer. So it's looking at different spectral bands at the atmosphere and measuring humidity and temperature, so you can complement the modelization. So what is particular there, as I said, it will be an operational mission, subject to the approval of the InnoSat program board. We expect this in 2025. Then this satellite will be the prototype model to a constellation which will be implemented after 2025. The idea is to have 6 satellites, 2 satellites per plane, 3 planes, so 6 satellites in parallel on at least 13 years of operations. So in total, it will be around 20 satellites to be procured. And to cover the different orbital plane, we had to look at different configuration, especially for the power subsystem. And this is a further enabler for our product line, because now we have a product adapted to different plane with different configuration, and as I said before, improve reliability for operational missions. Then the next in a row is ICE. So this is an Horizon 2020 IOD mission, contracted by ESA, but financed by the EU. And there are also a new sort of requirements and further enhancement of our product. So it's about flying a hyperspectral instrument from AMOS. So it's in Venir and SWIR. So it's for agriculture, pollution, other type of application. And there we had a very strong requirement in terms of pointing stability, pointing accuracy, and also agility. So on this mission, for example, we have to be able to roll the satellite on its axis by 60 degrees in 1 minute. So what does it mean? And roll and stabilize so that you can take the next picture. Just to illustrate this, basically imagine an orbit going above Paris. You'll be able to make a picture of Bordeaux, and then on the same orbit, take a picture of Strasbourg. So imagine, okay, it's quite far, but don't forget the satellite is flying on ground at 7 kilometers per second. So that really shows the capability of the satellite. And as I say, this is a further enhancement. A bit heavier, and here also in terms of launch, like for Arctic weather, the launch will be in 2024. So that was the 4th satellite, and this week we had the honor to be able to announce our first commercial customer. So this is based also on our InnoSat product line, very much reuse of the ICE design. This is also an optical mission together with our partner, so Satlantis and customer. So Satlantis is providing the optical instrument you can see here on the renderings. So, and with this mission, we can achieve high resolution in different spectral bands, visible, Venir, SWIR. We have also new IOCS modes, because there you have to follow the pipelines, or if you follow the rivers, depending what you want to look at, and the high data rate. So there also, in our modularity, we add new functionalities, new level of performance. And this is also to prepare ourselves for future mission. Purpose of this, there are different ones. Potential ones are to look at the methane gas or oil, any type of greenhouse gases, but also some agricultural application. There also, the launch will be for the 2 satellites, so InnoSat 5 and 6. It will be in 2024. So you see a lot of things happening with our product line. That's why I'm honored to be able to present it today, because it's a milestone this week that we could achieve this on the commercial market, and that's really increasing the pace at which we develop now and sell this product. So what about the future? So this was more the present, but we are of course looking at other type of missions where we can reuse what we have developed in the previous missions. thanks to the support of SNSA, thanks to the support of ESA, and also customers. And we can go down to other missions. So one we are looking at is this auroral oval monitoring. So it's in the frame of the ESA space safety program. So there, it's about looking at the interaction of the solar wind with the atmosphere. So at least in Sweden, there's one event we can remember. Well, I was not in Sweden at that time, but I've heard about it. In 2013, there was a blackout in the Malmö region because of a strong interaction of solar wind with the electrical system there. And to try to anticipate this type of incident, the idea of such a mission is to really monitor 24/7 what happens with the solar wind and what could be the potential impact. So there, the idea is to have two types of missions. So the first one, a demonstrator to qualify the technical solution. But another one would be to look at the constellation later, once we have finalized the protoflight model, to look at the constellation to operationalize the mission. So that's the future. And this, of course, depending on the support of the delegation at the next MISU conference, obviously. But we are not stopping there. We want to further improve our product. So we have a series of R&D activities running. Also, they are supported by the agency, ESA, and also Rumstyrelse, Swedish National Space Agency, to further improve our product. So that's around autonomy, that's around agility with the control momentum gyro, and that's because the autonomy and also the possibility to improve the management of the constellation and the autonomy of our satellites is contributing to reducing the operational cost of our satellites. So that's the idea behind this R&D. And this, again, supported by our industrial team, our team, and of course, the agencies. So just to conclude, and after we have time for questions, on our platform, so again, to look back at all the different missions we have been looking at, InnoSat, our platform, so we call it this platform of choice because we think this is the right balance between performance and competitiveness, offering the good level of reliability necessary for operational missions. As we have seen, we have been selected for this Arctic weather mission because we are able to demonstrate a good level of reliability for a mission, for a METSAT later, so with high requirements there. Modular, we are able to reuse a lot from the different missions, so improving our competitiveness. As I say, starting from the core avionics, which we have developed in the frame of the MATS mission. Scalable, we have seen today that we can cover missions from 50 kilo to 140, but these are not the boundary. I mean, we think we can go to 300 kilo, just a matter of adapting the structure, because in terms of power, I could show you that we are able to really cover high level of power as well. And we have, thanks to the development we do for the Arctic weather missions, different configuration already available. So it's evolutive, and it's flight proven. As I say, we launched our first satellite in January 2021 with this GMST mission after this very short development time. And this gives us very valuable data for our satellites. And this November, or October, if we look at 31st of October, if we look at the European time, we will launch our second mission with MATS from New Zealand. So this will give us even more heritage or experience on our platform. So this is, as I say, now based on all the past development, really a product which we think is fit for both institutional mission, but as well also commercial mission, as demonstrated this week with our announcement of the agreement with Satlantis. So that's about the product. So I don't know if you have any questions. I will look on this Slider tool. Okay, here there's no question. Maybe here any questions about the product or OHB Sweden? Yes, there? I don't know if you have a micro, I don't know. Someone is running to you.
Okay. What would be the interest for a customer to go for a hyperspectral satellite compared to multispectral satellites?
So hyperspectral, I mean the multispectral, you are looking at a few spectral bands, which are very specific. With hyperspectral, you are covering a much broader spectral domain, and you have a much tiny analysis of these different spectral bands. So you can really look at many more information than what you could do on the multispectral. So, but that's the point is, today this technology is developing. You need to develop the applications linked to hyperspectral. But it's like a Swiss knife. So you have a lot of possibilities just to find, you need to find out what you can do with it. And that's why I think now we have Nmap, which has been launched a few months ago, which has been developed by OHB system. And this is a good case to study what can be done with this type of technology. And with ICE, we will have the next model to also complement this. Yes. Yes, there.
Hello. If I understood well, and I may be wrong, you procured the launch to Rocket Lab yourself. Does that mean that you transfer the ownership of the spacecraft once in orbit? Or if it's not the case, is it planned for some of your spacecraft that you could sell the spacecraft directly on orbit or not on the ground before launch?
There are different cases. On MATS, we are the owner of the satellite. Of course, it's operated for the scientific community, but we are the owner. That's, I mean, an agreement we made with the Swedish agency. So here there's no transfer in orbit, but yeah. But we are procuring the launch, but via the agency. But there are other cases. I mean, usually on the ESA program, you know, it's delivery on ground at liftoff. The property is transferred to ESA. On Satlantis, it's a different business model from our customer, and there. Yes, the satellite may be sold before the launch or after the launch. It depends when this will happen. So there are different models. Yeah. Yes?
Merci. Joël from the French Space Agency. Thanks for your presentation and for your ready-to-use platform. I have a question which is, let's say, in the middle. You talk about Agile MVP. This method was already used by the teams, and how do they adopt this method to develop this kind of platform, the Agile method? Ah,
okay. Yes. So you mean in terms of Agile design methodology? So what I mean with Agile, I mean that our team is is able to really adapt to the requirements of our customer and put the focus on what is necessary. I was not meaning directly the Agile engineering methodology, but this we apply especially for our onboard software, where we run sprints of 4 weeks to develop our software in a very short time. So actually, that's also one strength of OHB Sweden, is that our effort, now that we have an existing onboard software, to adapt it to the next mission is very limited, which helps us to be competitive also on the commercial market. Any question? Good. Then we are in time, which we are used to be. 3 minutes left. That's what we have shown with GMST. We were... Ah, there's a question? Ah, okay. Oh, yes, there's a few questions. Thank you, Alessandra. So, the one question is, what part of the value chain do you cover? So, you deleted the question before I could read it completely. Okay, I understood that the question is about the value chain, about the launch. So we are a system integrator. So that means that our philosophy is that we do the system engineering at system level, but we want to rely on the expertise of our suppliers. So we do the complete system design. We take care of breaking down the requirements from the mission to the satellites and down to the different subsystems and equipment. And we have a long-term partnership with our suppliers, which deliver to us their product. And we rely and we of course check, that's the case, about their competitiveness. But we are convinced that a supplier who sells their expertise product to several customers will be more competitive than if we would try on our own to develop and build all of them in-house. So I know that this is a debate because some of our competitors have a very strong vertical integration. But let's say for the moment, I'm not convinced on the long term that this will work. Because I think, as I say, that someone selling to different customers will be more keen to be competitive on the long run. So, and the launch, it depends on the mission. As I say, for MATS, we procure the launch, but supported by SNSA. In general, we don't do that. But the OHB group has a launch broker. So this can be also offered together as a turnkey solution to our customers. The next question is, you mentioned the avionics being at the heart of InnoSat design, remaining unchanged throughout all missions. Okay, so what I mean with that is that we have an onboard computer, we have a power control distribution units, and we have onboard software and OCS algorithms, which are very similar from mission to missions. And the only thing we need to do is to adapt slightly. And since we have already covered a lot of different interfaces with this equipment, usually the only adaptation is to be done on the software side. And as I mentioned before, we have also agile methodology. We have a catalog with different modules of the software. The architecture is such that you have also different layers, and we only need to modify the upper layer of our software. So that's why we can reuse a lot from one mission to another. The next one, are you currently experiencing any significant impact in terms of component lead times in order to keep up this agile development approach? Yes, so the components, triple-E components, lead times, I think it's an issue faced by the industry overall. So for the moment, what we have observed is sometimes the lead time increase from a few months to 8 months or 12 months on our equipment. So we are in constant contact with our suppliers to mitigate this. We find some ways to reduce this, but that's clearly something we have to face with. But for the moment, it's still in line with the commitment we have entered with our customers. So, exactly on time. Thank you for your attention. I hope I could entertain you until the next agenda point. And if you have any further questions, I will be around until tomorrow, and then a colleague of mine will be there. So we'll be either at the Swedish booth or at OHB booth. So, and then if you want to contact us, just leave your name and we will keep in touch. Okay, thank you.